Hello, am I audible?
Good morning, sir.
Hi.
Good morning, sir.
Good morning. So yeah, we can just wait for another 3-4 minutes so that whoever wants to join can join. Meanwhile, how is it going on? How's the course content and how is your effort and how are you liking the content so much? It's good.
To be honest, sir, for starters, like if we haven't studied derivatives and all previously,
Okay,
I have to consult some other sources as well
I see.
Yes, sir.
because these videos I think is not enough because the question which are asking and the content they are releasing, I know they are relevant, but not from beginners' perspective, in my
Yes,
opinion.
sir.
I see. I see. So we'll take this as maybe a constructive feedback and we'll see what we can do with this. Yeah, but, let's see. Anyways, we have live sessions, so you can ask us here. But right, since you have to attend this practice assignments and graded assignments, and this is something we expect after watching the videos, it will be like you need to solve them, right? Should be able to solve them, but unfortunately not able to do. But let's see how we can do that.
Yes, sir. Open session is definitely beneficial. If open session were not in that place, we were not able to solve any questions. I mean, 50% of questions.
So anybody, any other concern regarding, let's say, the running week?
Sir, in final exam, all the 12-week question is asked.
So in maths, there are only 11 weeks. 12th week is like revision videos. So
In
all
final,
11. Yeah.
in second term, only 5th to 8th week is asked.
Sorry, what?
In second term on 10th July.
Uh-huh. What is your question on 10th July? What?
Week 5 to 8 is asked on exam on 1 to 8.
No, week 5 to 8. More emphasis to week 5 to 8. Like it will be like you can expect like 90 to 95% of questions coming from this week.
Okay.
And what about end term, sir?
End term entire week.
Okay.
But you should always pay attention to what is not been asked. Like let's say when you go to end term, the graph theory won't be asked, right? So it will have slightly higher weightage compared to any other weeks. So it's like that. But always what we tend to do is like we keep almost similar weightage for all the weeks.
Okay.
That's our approach. But we also be more biased towards the week, those graph theory part, because that is never asked. We never tested you on those questions, right? So that's how it is. Yeah. So how many of you have gone through week 8 content?
Me, sir.
You have gone through? Okay.
Yeah.
So roughly this is what topic you would see, right? First is limits, then continuity, and then differentiability, and then limits and derivatives using L'Hopital's rule, and then equations of a tangent at a point on a curve. Now this is the whole broad topic that we would do, right? So what we will be doing today is we'll try to cover as much as possible. So what I have thought of doing is like I'll discuss this concepts quickly. All of us will participate in that, and participate in the sense I'll be asking you, I'll be putting up questions here, and then you can solve with me, and you can solve by yourself and give me the answers. Even I'll be solving with you. So that is how we'll do, and we'll try to do all the questions
louder.
Okay, still louder. Is it fine now?
Yeah, it's fine, sir.
Okay, so what we'll do is we'll try to touch up more questions today, because that is where we understand, because this is how when I used to learn in during my college days. So what I used to do was I used to solve various number of problems, because if somebody tells you, okay, this is what formula or this is what the concept is, now do the problem, it becomes very hard. Until or unless we do the question, the concept does not get clear. So my approach is I'll discuss as much problems I can, And maybe I can discuss both mathematically as well as graphically, so that we'll have idea that what is happening here, right? When we see, whenever you do any problem in mathematics, let's say if it is anything, and if you want to solve that question, so if you can visualize that problem, then 50-60% of your problem is solved, right? For an example, let's say a graphing of polynomials, or let's say a graphing of another functions like exponential or logarithmic, right? The moment you draw the graph, you know what to do now, right? You can tell everything of that functions, right? Almost everything of that function, isn't it? So what I give more emphasis to is like how to visualize those functions and how do we actually solve it, right? So that is something we'll do. Maybe we'll do some maybe like 15 questions, 15 to 20 questions if we have time. So that is something like I have thought of, but let's see how does it goes, right? So this is something, these many topics we'll try to cover today. Maybe a quick summary, and then we can take up more questions. So it will be like giving you a summarizing a concept, let's say a limit, or let's say a continuity, and then I discuss the concept, and then I take up some questions, right? So this is how it will go. Okay, so let's do it. And since this is the entire of week 8, so maybe I'm not covering entire concepts, but at least I'll give you an gist like what is happening there, right? And I think some of you have gone through the lectures already, so it will be a kind of revision to you. So I have written something prior to coming to this session. So you see this. First, as I told you, it's like limits, right? So we know that when do you say a limit exists? So first of all, you should actually say there are two conditions whenever you say the limit exists. So what are those two conditions? So you say this. First is the left hand limit and the right hand limit should exist. You know, give emphasis to this word, should exist. Should exist means what? It should give you some proper value. It should give you like 5, 6, -8, or 12, or whatever. It shouldn't go to infinity, right? So when I'm finding left hand limit for a function and it gives me a value infinity, or let's say a minus infinity, then I say it does not exist, right? Or let's say maybe at some point of time the function is not defined. In that point we cannot say it exists or not. That is some different topic or a different concept, so we can talk about that later on. But what I'm trying to say here is the left hand limit and right hand limit should exist. Should exist means it should give some proper values. Also, this left hand limit, so left hand limit, so I'm just writing in the short form, that is LHL, and right hand limit RHL, right? So this LHL should be equals to RHL, right? So when these two are happening, then I say the limiting exists. Okay, I hope that is okay. So you see, you have to participate with me. Okay, so if you don't talk, I will assume that you understood this, and maybe a fine time I'll throw a random question just to check whether you know that or not. Okay.
Okay, sir.
Sure,
Sir,
sir.
I have a
So
small query over here. That,
participate with me. Okay. So that's all.
can I ask something?
Sure, go ahead.
The thing is that if these two things happening, that means the limit is exist. Okay.
Right.
If the first one only happening, that means the curve is not continuous.
Yeah. So if
And
just the
if
first one is happening,
yes, and this if that thing is happening, only left limit exists and right limit not exist, then what happens?
you see this curve. Okay. Maybe this one, and let's say this one. Okay. So you see the left hand limit exists, the right hand also exists, right?
Yes.
So you are saying it is
One thing is not exist. That step function is on the two limit exist, but they are not continuous.
Right.
But I'm saying only one limit exists and other limit not exist. Then what is that called? What is this?
then the limit does not exist. Both
That's,
the limit has to exist.
but how like if the only one thing is happening, that means the first thing, that is mean this is not continuous, like step function.
So you cannot say that, because you see this. Look at this function.
Okay.
Look at this function. What is left hand limit for this? Let's say if this is something like 2. What is left hand limit? 2. What is right hand limit? 2. Okay, sorry.
Okay.
So the limit exists, but what do you mean to say is when can this happen, right? So when you're saying this exists, if this exists, then can I say this LHL is always equals to RHL? Is it?
No, I'm just saying that the
Whether
second.
it will be discontinuous when the second condition does not exist, right? Yeah, that is
Right.
perfectly right. Yeah.
I'm just saying that suppose this kind of happened that left limit is 2 and right limit is infinity. Then how the graphs look like and what is this called? Is
Okay,
this
so
thing?
you can say that there might be some situations. For an example, if I have to tell you, let's say if this is my curve, okay, and yeah, so let's say my left hand limit exists, you say, right? So
Yes.
here I say it exists,
Okay.
but look at this,
Uh,
right? So
yes.
what is your right hand limit in this case?
Infinity.
It does not exist, right?
Does not. Okay.
So you got one example, right? So you can
Okay.
think about it.
And that's
All
why I'm
right.
asking because I cannot see this thing. That's why I asked.
Sure, no problem. So, all
Thank you.
right. So let's start with our thing and keep asking questions. Maybe I'll finish a concept and then you can ask me a question. Okay, so that is how we can do. Okay. So
Sure.
let's say now I'm discussing limits and let me finish this limits and then we can go with asking questions and all that. Okay. So now you see this. So you understood that, like, if the left hand limit and the right hand limit, first it should exist and LHL should be equals to RHL. If these two is happening, then I say what? The limit exists. Okay. So what do you really mean by this LHL and RHL? So LHL is nothing but left hand limit. So let's say if this is a straight line, or let's say this is a point, and this is, let's say, my curve, and let's say this is 2 feet above. So can I say this point as 0,2 if this is my x-axis? So and this is my y-axis. So if this is my curve, so what do you really mean by this left hand limit and right hand limit? So left hand limit means you're approaching, let's say, this point from left hand side, and over here when you say right hand limit, so you're approaching from this side to this part. Okay. So when you're approaching means what? You are coming, you are basically increasing your x, right? So this is what you are doing, right? In this case, so you are moving towards this point or this x values. So x values of that. So LHL or RHL, it's actually the values of this function, right? If you look at this, it is actually the values of this function. So can I say this LHL is equals to 2, or should I say LHL is equals to 0?
LHL is equal to 2.
2. But again, what is our limit? Limit x tends to
0.
0, right? So what do you write? You actually write the value, not the x, right? Whenever you do this. So keep this in mind, because most of the time what happens when we start solving the questions, then we sometimes happen to choose the x value rather than f of x value. So pay attention to this. That whenever you find the limit, you actually find the output of that function at that when that x tends to that value. Okay. So it's just a caution when you're solving a problem. So now, having known this, like what is limits, so what do you really mean by this mathematically? So you represent this way. Your left hand limit is basically limit x tends to, let's say, a, that is x is going to a, from this sign indicates that you are coming from left hand side to this function f of x. So whatever the value you get, that is your left hand limit. And similarly, when you approach the functional value from the positive from to a from the right hand side, then that functional value is nothing but your RHL. Okay. So this is just a quick example to tell you how is this happening. Again, let me give you another example. So now this is my function f of x. Okay. So what are we doing here is, so you see this, I have defined this function like this. Now, when x is greater than 0, then the output value, that is my f of x, is x, and when x is lesser than 0, this is going to be minus x. So could you tell me why is this circled here and it is empty at this value? Because look at this, my functions. This is my f of x. If this is my f of x, is my function defined at x equals to 0?
No, sir.
No. That is why you see this void here. Okay. So now what? So now let's find the left hand limit and right hand limit. Okay. So now look at this function. When you are approaching to this point. Now, when I say that you're finding left-hand limit, so to what? So now you have to tell me where should I find the left-hand limit? So you should, here in the question it says that, okay, fine. You are tending to zero, right? You are tending to zero, and then you have to find out what is the left hand limit. So this is what we are doing. So when you do this left hand limit, when x tends to zero, f of x is zero, and right hand limit, again you do it similarly, and you get it zero. So do you think, do these 2 points exist? Zero and zero, it exists. So first condition is satisfied. Exist in the sense it gives me some values, right? So first condition is satisfied. Now second condition says that both of them has to be equal. Now is my LHL equals to RHL? The answer is yes. So if these two are happening, can I say that limit exists
Yes.
at equals to
Zero.
zero, right? So this is what right? So we can say that
Yes,
limit
sir.
exists at x equals to 0. All right. So now having seen this function, could you tell me something about this function? Okay, so you just have to tell me whether the limit exists for this particular functions. Maybe this is open like this. Of course, I think you can tell this because I have already discussed. Huh. So do limit exist if I say this is, let's say this is 2 and let's say this is somewhere like tending to 3. So do limit exist as x tends to, let's say, 0?
No, sir.
No, sir.
Why?
Because left hand limit is different from right hand limit.
So which condition from this, which condition is being violated?
Two, second condition.
Second condition, right?
Second
So because limit exists, the left hand limit and right hand limit exists, right? Because you tell me what is LHL? When you approach this functional value from the left hand side, what do you get output when your x tends to 0? So what do
Three,
you get?
sir.
You get 3. And what about your RHL? When x
Two.
tends to 0 positive, so it goes to 2. So what do you notice this?
Both are not equal.
They exist, but they are not equal. Therefore, the limit does not exist for this particular function. Okay, and how do you see graphically? So graphically, you see that there is kind of a breakage in the function. Breakage in the sense, you see this, there is a kind of breakage over here, right? Of course,
Right,
the
sir.
breakage is not the right word to say because there is a breakage over here too, because this function is not defined and you have to lift your pen and then go somewhere, right? So that's what you do. Similarly, you see this, you can understand, right? So there is some kind of discontinuity. That means there is some kind of gap in the values of those functions, right? And therefore, you can say that, okay, the limit does not exist for that particular function. Now let's go to continuity, okay? We can discuss more problems on this, but let's understand what do we really mean. So let me finish this continuity and then I'll take up the questions together and we can discuss more questions, okay? So now see this is the definition of continuity, okay? So now you see this in continuity, there are two conditions again. First of all, the first condition says that limit should exist at that point A, okay? And the second condition says that the functional value should be same as the limit value. Now, if that is too much, then I'll explain you again. First of all, first condition says what? The limit should exist. That means what? These two conditions should fulfill. That is the first two conditions what we have written here in the limit, right? So when does that happen? LHL and RHL should exist and LHL should be equals to RHL. Let's say that gives us some value B, right? So this is what? The limit should exist at that point. Okay, so now I got this. Okay, so now I say that, okay, the limit exists. Now second condition says what? Now you see this, most of the time we also get confused with this terms. When I say that limit x tends to a, f of x, this actually means what? On just, I can say that not very specifically, but yeah, at most of the cases, this is what you see that when
A positive.
so this is what we do, right? So when you say this, let's say if this is happening true, let's say this is giving some value a and a, so I can simply say that limit x tends to a, f of x is actually giving me a, right? So how am I doing internally is I'm doing this first, right? And then I'm telling this that limit when x tends to a, f of x is a, right? So this is what I'm doing internally, and finally I can write that limit values. All right. So I hope you understood that much. So now let's understand this part which we left here. So now it says that what limit x tends to a, f of a is actually equals to f of a. Now what do you really mean by this? All you have to do is this value, you substitute in the function and you see what you get. Okay. So it is that simple. Now let's understand with this and here in this particular example only. So now you see this over here in this particular example, let's say this was example one. In example one, what did we see? The limit exists for this function, right? We all know, right?
Right,
Yes,
sir.
sir.
So over here, first condition is satisfied. Now what about the second condition? Second condition says what? Second conditions, you always do this, right? You check this. So now what is f? What was my limit value over here? X was tending to 0, right? So what is f of 0?
0.
Not defined, sir.
Not defined. Because
Not defined.
look at this function. This is what I have defined my function, right? Have I defined for 0?
No.
No. So when I haven't defined for this 0, that means there is not defined. This function is not defined at this where f of 0. So do I say, now look at this, when I expand this, when I take up this, what is the value for this? I get 0. But what is the value for this? Not defined. So can I say both are equal? I cannot say that. Therefore, this is not a continuous function. Therefore, this function is not a continuous function. So now look at graphically. Even graphically, you can say that yes, there is some kind of void. So how do you understand whether something is continuous or not? So it basically means you can draw a curve without lifting a pen, right? So this is what you would have seen it in lecture as well. So now you see this. This is what we generally say, right? So now you see this. Can you draw this curve without lifting a pen? I think maybe yeah, because you see this, there is some kind of a void. You will always see there is some kind of breakage or a void or something like this, right? So understand this. Okay, so now you can say that yes, though this limit exists at this point, but it is not continuous. Okay. Now even the name signifies that. Okay, continuous means what? There is no gap at all, right? It is basically continuous functions, right? So even by the name, you can look at the graph and you can say that yes, this is what it means, right? So now having known these two things, now let's discuss more on this. Now we understood first this, just a minute. So now we understood this part, like, okay, having known that you haven't understood that well, what is continuity, we can discuss more problem and we can understand this. But for time being, let me just summarize it here. For limit to exist, these two conditions has to be satisfied. And for continuity to exist, again, these two conditions has to be satisfied. Like the limit should exist, and second, the functional value should actually be equals to the limit value. Okay, so these are the two conditions for this. All right, so now tell me if you have any doubt.
Just the one you shared before in the limit section at the last I asked.
Sorry.
Why it was not, it was not continuous, right? And it was there was no limit. So can you please explain why there is no limit, even though we want some value?
The first example what we drew, is it?
Yeah.
You mean to say this function, this one which I drew at that point?
Yes.
Is it?
Yes.
So now look at this. This is the limit does not over here. Now again, look at this definition, continuity definition. Now what do you see here? Now let's say this is some giving me some values, and let's try to solve this question. So this, let's say this is giving me 2 and this is giving me 3, and let's say my x-axis is here. Always I'm kind of giving you 0. So let's say this is 0 and let's say this is 1. So now what I say that limit x tends to, and let's say this is my function f of x. Now what do you see? Limit x tends to 1 minus for f of x. What do you get the value? Let's say
We
this is
will
3.
approach it from the left hand side, and since 2, there is a gap in 2, so we will take the value of 3, right?
What should I get the output here for this particular function? 3, is it?
3.
3.
Okay. Now what about this? Limit x tends to 1, yeah, let's say 1 plus f of x.
Not defined.
2, sir.
2.
2.
2.
tends to this value. It's not, they are not asking you the exact value. Look at this symbol. It says that when you approach to that value, what is your functional value approaching to, right? This is what it means. Okay, so now you see this. Do left hand limit exist? Yes. Do right hand limit exist? Yes. But are
Yes.
they equal? No, they are not equal. So can I say that limit x tends to 1, f of x exist or do not exist?
Do not exist.
Do not exist.
Do not exist. So if this do not exist, so the first condition of continuity is failed. Therefore, I can say that this is not continuous. Or can you tell me what is functional value at 1? What is f of 1?
F of 1 is actually two values.
sir.
So
it can't be
possible.
3, sir, 3.
3, it is possible.
3.
Because look at this,
Three.
look at this graph. At 1, it tells us the value 3. Right?
Sir, in this example, if we don't have this graph down one, which is approaching to 2, then in that case, what is our right hand limit?
In that case, you will not find your right hand limit.
Right hand limit will be undefined for this.
No, no, no. It's, you cannot say undefined. It's basically this function is not defined, right? Since the function is not defined, so you will not find the limit at that for undefined functions, right?
Sir, one more question. Sir, if let's take polynomials in denominator and numerator. So if a function, let's say fx a is not defined for that polynomial, like we are getting 0 in the denominator. So even though we can get the limit, it is possible that limit exists on that polynomial, right?
You saw this, no? You see this example,
Yes.
this one.
Yes, that's why I'm asking. Actually, I was not clear.
Possible because you see, look at this symbol. It says what? It goes to that particular value, and when you say equal to, that means you are finding the exact value, right? Now look at this part. When I say f of 1, so what do I really mean by this? What is the exact value of this function at x equals to 1? Right? So these are the difference. Yes. So now, do any of you think like, why do we always look at these values at some breakage point? Why don't we look for the limit value at this point or that point? Now let me ask you here itself. Let's say this is 2, okay, and let's say this is 2.5. This is my value 2.5. So what is the limit when x tends to 2?
2.5.
2.5.
2.5.
2.5. Okay, so what is my left hand limit?
2.5.
2.5. And what is my right hand limit?
2.5.
So what do we really mean by this? So you are going to this particular value, that is at, you are going to this x equals to 2. From where? From left hand side. So which is that region you go through? This is what you go through. So when you go to this part, what is the output value you are tending to? 2.5. And when you are coming from this part, that is positive, that is from right hand side, and you are approaching. So what is the value you are approaching for? 2.5.
2.5.
Right? So in both the cases, it is 2.5. Therefore, I can say that limit exists at this point, right? So now this is some understanding that we got it. Okay. So why do we really check for one? Because most of the question will say, okay, find limit at this point. Why don't we ask you to find that limit at these particular things, right? So now there is some understanding over here. So let's do that understanding first, okay? And then I can switch to the other things. Now look at this part. Maybe I can just draw some graphs and explain you. Okay, so let me take it here. Now we have studied what? Now we have studied some straight lines, right? Now look at this straight line. Let's say this is my b. So this is my equation, y is equals to, let's say, mx plus b. Okay. So is this, what is the domain for this function, first of all? Domain is what?
Real line.
Real number. Okay. So can I say this function is, do limit exist at all r? Is my question.
Yes.
Yes.
Yes, sir. Continue.
Limit exists
Because it continues, I think.
over r. Right? So at everywhere the limit exists. Now what do you really mean by that? Now look at this place. I just give you an example and then I can just conclude this with some values. Now let's say this is 2. So now what happens? So what do I really mean? limit x tends to 2, f of, let's say this is my function. Maybe I should not say y, but let me just take this f of x. So limit x tends to 2 f of x. What do I get the value? 3.
3.
Three.
So what do we really mean by this? When you are approaching 2, what is my functional value that I'm getting? What is
Three.
my functional
3.
value it approaches? So
Three.
you do from the left hand side or right hand side, and no matter wherever you do, it is the limit exists over R. Similarly, look at this. Now the limit f of x is equals to 3. But what is f of 2? F of 2 is 3, right? So can I say that this is a continuous,
Continuous.
right? So I can say that this is continuous on R.
So,
this is-
sir, by the limit, we can say about the continuity of the function. Yeah, am I right?
Yes, definitely. With
So-
limits, you can talk about the continuity of function, because that is in the definition of a continuity. That is the first condition, that the limit should exist, right?
That's why we study limits. That is the reason, or something like
Yes,
this.
you can say that. But again, you will go to differentiability. Again, for differentiability, you need that limit and continuity, right? So you can say again, you study limit because of differentiability, right? So this is how you can build up as you are going through. But for time being, you can say that yes, this is what one thing is. So now we understood that. We understood the domain. Now this is basically a straight line, right? So if I give you a straight line and I say you the limit exists at any point, then can you say yes just by not thinking anything? Yes, you can say, you can just blindly say that yes. Yes, we can blindly say that yes, the limit exists over R. And I can also say it is continuous over R. So I don't have to think at all, right? Likewise, if I go for a quadratic equation, let's say this is my quadratic equation and this is my function f of x, which is, let's say this is b. So this is going to be x square plus b, right? So if this is my function, x square plus b, look at this function. Is this continuous over R?
Yes, sir.
Yes.
Just I directly asked you. The limit exists, so entire condition of this is being fulfilled over here too, right? So all this
Yes.
condition is being fulfilled here, right? So now what do you see this? I can just erase this. So, and this was what? Quadratic. So look at this. What are we saying here is a straight line, a quadratic. The limit exists on all over R, and also what? It is continuous over R. So I don't really have to check at each and every point whether the limit exists or not. Correct? Can I say that? Can I
We
say
can
that?
Yes,
also
sir.
conclude this for
Yes,
polynomials also,
Sir,
right?
I have a
Exactly.
question.
That's what I was going to. So now let me just finish this and then I'll take up your question. Is that okay?
Yes.
Let's say this is my function. Okay, so now this function goes something like this. Okay, and now again, look at this. This is a polynomial function. Let's say this is polynomial function. And could you tell me same thing about all these? The domain is R, the limit exists over R, and it is continuous over R. So can I
Yes.
say on general, so now basically a straight line is also a polynomial with degree 1. Quadratic equation is also, or a quadratic function is also a polynomial with degree 2, right? And polynomial means basically many degree other than 2. So it's like 3, 4, 5, 6, 7, and so on and so forth, right?
Yes.
So I can say that yes. So polynomial function on general is continuous over R, right?
Yes.
I have, now we should not have any doubt. So next time we
No.
should not ask why are we not finding limit at any particular region. Why? Because I have already generalized it, right? We have already generalized this, and this is something we assume and go that this is something all of us know. But this is just to give an emphasis to that this is what is happening. Okay. Now look at this exponential function, right? This is my exponential function. So let's say this is f of x is equals to e to the power of ax. Now this is my exponential function. Can I say the same thing for this as well?
Yes, sir.
I
Yes.
can say the same thing. Now let's go to the logarithmic functions. How the normal graph is something like this. So now look at this. F of x is equals to, let's say, log ax, where a is greater than 1. Okay. So now can I say that something, my domain is of course not R. My domain is all positive R. Over here, what is my domain? R positive.
Yes.
Right? So now in its domain, is this function continuous?
Yes, sir.
Yes, sir.
If a function is continuous, naturally it means that limit exists, right?
Yes.
Right, sir.
So I can also say that. Now, similarly, I can go with other function. Now, this is my logarithmic function. Now, look at the other functions too. There is two more functions I can just tell you. Now, look at this sine functions. We know that sine, right? Sine function is
Right,
something
sir.
like this, right? So this is, let's say this starts with 0, this is pi, and this is, let's say, minus pi, and so on and so forth. So this is my sine function. So let's say this is f of x is equals to sine x. Okay. So now can I say the same thing, that
Yes,
this
sir.
function is continuous over R? I
Yes,
can
sir.
say yes.
Yes, sir.
This is
Continuous.
Now look at this mod function. Okay, before going to mod function, now let's say if I have a f of x is equals to tan x, can I say this is continuous over R?
No.
No,
sir.
sir.
Oh,
No, sir.
okay. So I thought like you guys will tell like yes because it is again the same, but all of you are smart then. Good. So you know that how does the graph look like? Will you tell me?
Yes, sir.
Yes,
This
sir.
It is
is the
bounded
It is
by
discontinuous, sir. It is
And
not
And
defined
this is
over
pi by
pi
Pi
by
by
2. Pi by 2.
Ah,
Every multiples of pi by 2, it is not
odd
defined.
multiple.
At odd multiples.
odd
of
multiple
Yeah,
pi.
at
there.
odd
Only
multiples.
even it exists.
okay. So that is, then I feel like most of you know things, right? So it's good. So now if this is the case, so this is minus pi by 2. So now what? Now again, it starts with this. It goes like this, right? This is what happens,
Yes.
right?
But sir, like logarithmic functions, if we restrict the domain here and then ask about continuity, we can say
That
that.
is definitely right.
Right,
Yes,
sir?
yes, yes.
Yeah.
We can do that. Yeah, that is perfectly fine. But now see, look at this function. Okay. Now, what can you talk about continuity, or let's say, do limit exist at pi by 2?
No, sir. Not it.
No, because what is tan? What is tan 90?
undefined.
Infinity.
Not defined.
It's not defined, right?
Undefined, sir.
It's the moment you say not defined, then you know the limit itself does not exist. We can say so. We can say that this is not even continuous, and the limit also does not exist, right? So this is something I just wanted to check, like how present you are here. So that's good that you know that. Now look at this mod function. Now f of x is equals to mod function. So can I say that this is continuous over R?
Yes, sir.
Yes, sir.
So this time, less of few of you told yes. So look at this function. So this is going to be something like this. Okay. So now this is the graph for this mod function, right? So now look at this function. Can you talk anything about 0? Look at this part. Okay. So now what do you think? When you are approaching from left hand side and right hand side, the limit exists at 0, right? Because here
Yes.
itself we have that sharp turn. That is why we can think about here, right? So the limit does exist over here. And look at the functional value. So what do you say? Limit x tends to 0. F of x is what? It's giving me what? 0. And what is my functional value at 0? 0. So this is continuous. So f of x equals to mod x is basically a continuous function on R. Okay. So now next time, without any restriction, if this is being told, then we are not going to check what? Whether this function is continuous at that particular point or not, right? So we can only think of those points, let's say a breakage point where this function is not defined. So you might have a function sometimes like this. Look at this function. You might have a function like this one, this one. Now, what is this? This is basically a straight line, right? This is basically a straight line. So when I take R negative, when x belongs to R negative, this is a straight line. So I can say that at all point, this is definitely a continuous. Can I say that? At all
Yes.
points in R positive.
R pol
Sorry, R negative.
R negative.
And
negative.
this is basically a quadratic. And so when x belongs to R positive, can I say that this is again continuous at everywhere? I can
Yes,
say that.
sir.
Gladly.
Yes,
So
sir.
which is that point I should actually check for whether this function is continuous or not?
0.
Zero.
It is
Zero.
at this point. So this is something will give you a hint. Like, okay, fine. At all places, this is continuous, and at all other places, this is also continuous in its respective domains. But this is something which is creating a problem. So you should check continuity or differentiability, or let's say a limit exists or not at this point, right? Not at any other point, right? You understood? That is why we only check for these values, not at any other places, because we go with an assumption that you already know this. So now I hope you understood this part. Now I hope you got some understanding here. So if you got that, so let's try some questions over here. So now you can try some questions. So,
Sir, I have a question.
oh yeah, I didn't take up your questions. Yes, please tell me.
Sir, the last graph you draw,
Yeah.
in which the straight line was ending at a point in the and the quadratic equation was starting from another point. What if the straight line where it ends and the quadratic equation starts from right from there? So will it be a continuous?
Could you tell me again? Can you help me out? So this is one case.
Where it ends from right there, the quadratic equation starts.
From here or from here? Okay, from where it ends. Here.
Yeah.
Okay. So again, yes, this is continuous.
Okay.
Now again, why? Now that is the question. Now see, over R positive, this is definitely what? A continuous.
Yes.
Over R negative, this is a straight line, so this is continuous. You can only think of, okay, this function is changing at this point of time, right? So now you will think, look at the graph and see what happens. When you're approaching to 0 from left hand side, what is this value giving you? Some fixed value, let's say A. And when you're coming from right hand side, this is giving you some fixed value, let's say A. And this function does not have any breakage, right? So I can also say that f of A is giving me the exact value. If this is, sorry, f of 0 is giving me some value that is A. So I can say that, yes, this is continuous as well, right?
Yes, sir.
I hope you
Got
understood, right?
Yeah.
But had it been some kind of void over here, then you cannot say this thing. I mean, it is not continuous. Sorry, it is, yeah, it is not continuous anymore, but the limit exists.
Got it.
Okay, clear?
Yes, sir.
Clear? Okay. So now having no question, see, question
Excuse
number
me, sir.
1. So, okay, so now let's try this.
I have a doubt from like the graph number 2 of the quadratic function. So in that function, we said that limit exists over R. That is the real, that is the positive and the negative numbers. But in a quadratic function, we never get the output or the range as negative real numbers. So could we really say that limit exists over the negative
Over R
numbers
means
as well?
We are looking for X values, no?
see, basically there are two things, LHL and RHL. So these are the output values. And what I'm saying is limit exists over R means for all values of X.
Okay, so limit
You understood?
exists over R means like we are putting the values of X, which is anything like
Yes.
positive or
Which can be
negative.
anything.
Okay.
Correct.
Okay, got it, sir.
Okay. So now let's go with this particular. So now let's, this is our question. Okay. Now consider this function f tending from R to R. So this function is defined from R to R. So now you have to check whether, okay, so can you tell me, where will you check whether this function is, so whether the limit exists or not for this particular thing. So now where will you check for continuity, or let's say, let's not say continuity, but your question is, okay, maybe I did not. Let's just give me a minute, okay? Am I audible? Hello?
Yes,
Yes, sir.
you're
Yes, sir.
audible.
Yes, sir.
Am I audible?
Yes, sir, you
Yes,
are.
sir, you are.
All right. All right. Now, here is a particular question to all of us. Now, you have to tell me whether consider this function f2 function from R to R, and now you got to tell me uh, whether this function is continuous on R or not.
No, sir.
No, sir.
This is not continuous, sir. Because whenever f0 plus, then it will give 1, and whenever f0 minus, it will give 0. So both limit are not same.
So yes, by looking at the function, you can say, you can talk something about it. So how do we actually solve these particular questions? Okay, so when you ask a question like, okay, this is continuous over R or not. So what are the two conditions that you will check? First, the limit exists or not, and second, what is the second thing you'll do? Limit x tends to whatever that value, f of a should actually give me some value, let's say some b. Okay, so now let's do this. Now we know that. Now look at this function. Okay, now x, if x is lesser than or equals to 0, so maybe I can just draw the graph over here and we can understand this. When x is lesser than or equal to 0, I get x. So how does the graph look like for x? It's x, right? So it's something like this. It's basically y is equals to x. Understood? And it is going till
Yes,
where?
sir. X is y. Okay.
And it is going till where? Till 0, right? And after 0, it is giving me x plus 1. So x plus 1 means what? How will the graph look like for x plus 1? Basically, y-intercept is 1, right? So, and look at this. At x equals to 0, basically it's basically not defined, right? So I can just give this and go ahead like this. So this is basically giving me what? This is the graph for x, and this is basically x plus 1. So overall, this function is what? F of x.
Excuse
Right?
me, sir. How you said that x equal to 0 is not defined, because in function you have said less than or
No.
equal to 0.
When I was drawing this graph, I just told you that at this point in this, for this value at x equals to 0, on general for f of x, this is defined. That is totally right. But when I was drawing this graph, and why I gave you here as a void was just to tell you that. Okay. Now look at this graph. Looking at the graph, can I say that limit exists or not?
Limit exists, but
Limit.
not equal.
No, limit does not exist.
Limit will not exist, sir.
Limit does not
Which
exist.
but I mean, left limit exists, right limit also exists.
Both exist, but overall general.
Over
They are
general
not
not
equal.
exist. They are not equal. That's what I'm saying. Okay.
So now how do we do it mathematically? Okay. So now this is by, when I draw a graph, now I can talk, okay, this is not, the limit does not exist, and also it is not continuous. At what place? At x equals to 0. But rest all places it is continuous, right? That all of us are convinced, isn't it?
Yes, sir.
Yes.
Yes, sir.
Because this is a straight line, it is continuous on this domain, whatever the domain is. And over here too, this is also continuous in its whatever the fixed domain is. But only place I can check is x equals to 0, and that is why in questions particularly they'll ask you, okay, when limit x tends to this value, what is whether this function is continuous or the limit exists or not, right? So I hope you understand that why they ask you like that now. Okay, so now having known that much, now let's do it mathematically. Okay, so how do you do this? Limit exists or not? So I'm just taking this first case. What we do this LHL, and what it is tending towards 0 minus. So this is where I'll be checking where, because what is the breakage point? My breakage point is 0. So I'll be checking at 0. Rest all places it is continuous, so I'll not be checking, right? At only this place I'll be checking, isn't it? So now limit x tends to 0 minus f of x. What is the value I get? What is the value I get?
0.
0, sir. 0.
0.
And what about this? Limit x tends to 0 plus f of
1.
x.
1.
What do I get? 1.
1.
Is my limit x tends to 0 minus equal to limit x tends to 0 plus? Is this right?
No.
No,
No, sir.
It's not right. So limit exists or not?
not.
No, does not
I will
exist.
say that limit does not exist. So if the first condition itself violates it, can I talk about anything about continuity? Then directly I can say that this is not continuous. So therefore, f of x is
Not continuous.
not continuous. So this is done. So now we understood this, right? So if I have something figured like this, you can simply draw this graph and you can just visualize it. Okay, this is what he is talking about. You can just make a conclusion.
But
Right?
this graph is not given then.
Then I told you, right, how to do it mathematically. So you can use both the methods. I just told you, right, how to do it mathematically, right? So you can do it both ways.
Sir, and suppose that function was x is less than equal to 2, then x, and if x is greater than 2, so we will evaluate that x is equal to 2, right? Limit x tends
That is
to
what. That is what. You see, whenever the question is given like this, where can you see the transition is happening? At 0 only, right?
Okay.
Where is the transition happening? At 0. So that is the place you should check for its continuity. Okay. So now I hope you understood that, because at all other places this is going to be a continuous function, isn't it? Right? Clear? Okay. So having known that, you understood that.
Sir, if it would be like suppose x plus 1, like suppose it would be x plus only x, then limits exist because both sides they will approach to the 0. So that time will be.
You can say that. Okay. So over here too. Now this is a particular question, like question number 2 for this. Now this is a function given to us. Okay. Now you have to find all the point of discontinuity of this function. Okay. So this is the particular question to you. So could you tell me, is there any point of discontinuity for this particular question f of x? Question number 2. So
No,
try to
sir.
solve this. No.
No discontinuity points.
Why?
Because sin x upon x it is 1. So for x less than 0, it would be 1. And for x is equal to 0 and more than 0, it should also be 1. So all three conditions is equal to 1.
The left hand limit is -1, I think, sin x by x, because 0 minus h
Okay.
denominator.
Okay.
But if x is equal to 0, then we would 1, no? So,
okay. So whoever is telling there is no point of discontinuity for this particular function, that is right. But let's understand this out. Okay. So let's do this mathematically.
Excuse me, sir. While calculating the limits, we calculated left hand limit and right hand limit. Are we required to calculate the absolute value of the function at that particular point also?
That is for continuity, when you check for continuity, right?
Okay. So for limit, it's not really required.
It is required. See, continuity has to satisfy two sub definitions, right? First is the limit should exist, and second, the functional value should actually be equals to limit value.
Okay.
Right? So that's what you do, right? So there are two conditions that has to satisfy. Okay. So now look at this part. Okay. So now look at this. Is sin x a continuous function? Yes. Is x a continuous function? Yes. So when you divide or multiply or anything you do with this, it is again going to be a continuous function, but condition is in what domain? Look at this. When x becomes 0, this function will be not defined, right? But this function is for lesser than 0. So if you take lesser than 0 at every other places, this is going to be a continuous function, right? I hope you understood. I hope you're understanding this. So when x is lesser than 0, this is going to be continuous everywhere, right? And look at this, when x is greater than or equals to 0, this is basically a straight line. So that is also continuous. But where is the transition happening?
0.
Transition
0.
So that is where I will check for
Continuity.
Right? So rest all places I convinced myself that it is continuous. Now let us check. So there are two conditions for checking continuity, right? So what is the first condition? You have to check the limit, right? So limit x tends to, what is that I have to check for? At 0. So when you are tending from negative
0
side,
minus.
so sin x by x. So you know this formula, right? There is a formula, no? Limit x tends to 0. Sin x by x is nothing but what?
1.
1. So what do I get from here? I get 1. Likewise, limit x tends to 0 plus sin x by x is what? Again
1.
right? So this is what I get. Now this is my first condition, right? So now I can say that this implies what? Limit x tends to 0, f of x is what? 1, right? So my first condition is satisfied. What about the second condition? What is this? F of 0. So what do I get f of 0?
One.
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 So now can I
One,
say
sir.
that the limit value is actually equals to the functional value? That means can I say that limit x tends to 0, f of x is actually equals to f of 0? Yes. And what are these value equal to? It is equals to 1. So if this is happening, can I say that this is continuous?
Yes.
Yes, sir.
Therefore, this is continuous over R. Now you see, this is what I'm saying. What am I saying? Over R. Now, what do you understand by this? We convinced ourselves in the very beginning that when x is lesser than 0, then it is
It
continuous.
is continuous.
Or maybe I can say that in its domain, because I don't know what x is, right? It can be an integer or it can be a real number, right? So now you see this, we understood that when x was lesser than 0, this was going to be a continuous, and when x was greater than 0, this was a straight line, so this was continuous again. The only point that I'm checking is where it is not continuous. So that could be at one place, that is x is equals at x, what is the nature, what is the thing happening at x equals to 0 when x is 0, right? So that is where we checked it and we found that it is continuous there as well. So I can say that in its given domain, this is continuous everywhere. Now look at this particular question.
Sir, one quick doubt there. You have approached that question in two ways, one in layman terms and then in mathematical terms. So when we talk about the mathematical term specifically, when we evaluate the limits, then I think we should remember the standard limits function, for example, logarithmic, exponential, and trigonometric, which we have learned in week 7, I guess. So we have to remember that. Like sine x upon x is equal to 1.
See, most likely these are like very standard one that you can keep it in like 3, 4, or we ourselves will give you
Okay,
the
only
formula.
basic ones.
Just the basic one, not the complex one. Just this sin x by x, and also that e to the power of x minus 1 by x, and also this log 1. That's all.
But
These three
sin x
things.
by x, we can do that with L'Hopital rule
You
also.
can actually do all of them with L'Hopital's rule.
So that.
Okay. And sir, one more thing, you have also concluded that if two functions are adding, then we can say that they are continuous. So for addition, subtraction, multiplication, and division, can you summarize a little bit?
So now you can just take this, because when you're taking two functions and it's going to
fx
be,
and gx.
so you take this f of x and let's say g of x. So now you see this, if let's say this is continuous and this is continuous on R, let's say this is continuous on R and this is also continuous on R. So now what happens? Now you can think of, now if this is x and this is minus x, let's say, this is the worst thing we can have, right? Now when I add these two functions, what do I get? F of x plus g of x. What do I get?
0.
0. So now what can you talk about this? Is this a continuous function? Tell me something.
We can say that.
Yes, you can say that. Why? Because f of x is equals to 0. It's just this x-axis. Your graph is over here, right?
Right, sir.
So it is still, this is the worst thing you can think of, right? So the addition thing, I can say, okay, this is happening. Similarly, then I can say this is for minus. Now look at this, x sine x or something, right? So how will the graph look like for this one? Sine x graph is something like this.
Sinusoidal curves. Yeah.
And this gets amplified, right?
Right, sir.
So now you see this, it's hold true for all the things.
Okay, so if both
Yeah.
functions are continuous, then addition, subtraction, multiplication, and division all will be continuous.
But respect the domain.
Yeah,
Domain should
okay,
be-
respect domain.
Yeah. So that is fine. So you can say, you can talk about that. Now look at this function, f of x. Now here there is some concept that we will have to do. Find all point of discontinuity for this function, okay, of this function. So could you tell me something about this then? Is this function continuous over the
Sir,
given
if we
domain?
could first take this x squared to the denominator, we could form the sin x by x terms there.
Okay. What more you can do?
Then we could multiply and divide with 2 to get 2 by x in the denominator. So we could cancel out one term from there.
Okay, and
Then we can put the, like, check for the absolute values of x, like what can be possibly put there.
all right. So that is one way of thinking out, like, approaching that way. Now you know that you have learned something called sandwich principle. You know this? All of you know
Yes,
this?
we know
Yes.
this,
What
but
does,
Yes,
maybe I
sir.
can just give you an idea for those who don't know. What does sandwich principle says that for h of x lesser than or equals to f of x, which is lesser than or equals to g of x. Now, could you look at this function f of x? The value of this function is between h of x and g of x, right? Can I say this? F of x is sandwiched between these two functions. So when I write this g of x and h of x and f of x, what do we really mean by this? We are talking about the values, not the x. Understand this, right? G of x gives you what? Output. F of x gives you what? Output. H of x gives you what? Output. So you see the output value of h of x is lesser than f of x and g of x. Or in other word, I can say that uh, the output value of f of x is always between the values h of x and g of x. Can I say this? So
yes,
f of x value is sandwiched between these two things. Now this is I'm writing the definition, but I'm just explaining each and everything, and then I move to this. Now look at this. Now when I say this, for h of x lesser than or equal to f of x, which is lesser than or equals to g of x, if now I'm writing this sandwich principle, okay? So if you want, you can take a note of it, and it's extensively discussed in the lecture as well, so you can see that. So this is sandwich principle. Now what does this tells us? Now if I have to tell that if limit x tends to a, h of x, now what am I doing? I'm just taking limit to this entire function, okay? I'm just applying this limit to this entire functions, what I have written here, right? And limit x tends to a, g of x. Okay, so now what does it tells you? That if I have taken limit on all the sides, now let's say this, when x tends to a, f of x, whatever the value it is giving me, let's say it is giving me 10, okay, and this is giving me 10. If this
and
limit
middle will
x,
also be written.
so if this is giving me 10 and this is giving me 10, then this should definitely give me 10. This is what sandwich principle tells us. Okay, I hope this is understandable. I hope you understood this. So having known this, that you understood, now I'll tell you again, like if this goes to some value, let's say this goes to some value particular b, and this also goes to particular, that means it is going to the same value. If this is happening, and I told you that the output value is in between these two things, if these two are same, then naturally this has to be same, right? So this is b again, right? So this is what sandwich principle tells us. All right, so now look at this function. Now look at this function sine x. We know that sine x function is what? A continuous function, right? And x square is again a continuous function, and the product of two continuous function is again what? A continuous function. But where can something trigger you? When this x becomes 0, this will create a problem because this will become undefined, right? So but anyways, this function says that when x is not equals to 0, then this is something, it's telling us that yes, at that particular point you are not using these functions. That means for this part, for this given condition, I can say that this f of x is definitely a continuous. Can I say that? Can I say that? Answer is yes.
Yes.
Sir,
I can say that. But the only place that I have to worry about is at x
0.
equals to 0, right? So that is the only
Yes.
place that I have to worry. Otherwise, except 0, that is r, except 0, this function is defined everywhere, or basically it is continuous everywhere, right? The only place is disturbing me is at x equals to 0. So that is where I'll check for its discontinuity. So there is no standard way of doing it the way we were doing for these kind of questions. So, but one always, whenever you get a product kind of functions, it should always trigger you that, okay, there is something called sandwich that I can use it here. Okay, because you see this, there are two kind of functions here. So now let's understand this, okay? So now, maybe I can just give it as, let's take this as, just keep it as 2, no problem. Okay, so now just look at this function, okay?
This method is very time consuming, sir.
So
Just
sine 2 by x.
visualizing.
Okay, so now when I write this function sine 2 by x, what is the maximum value of this function? Sine 2x, sine 2 by x. What is the maximum value of this function? I'm telling value. Maximum value is, or basically I
One,
can say
sir.
that maximum
One.
value is 1. It will definitely be less.
1.
It will lie between 0 to 1.
So it will lie between 0 to minus 1. Sorry, not 0, but minus 1 to 1.
Minus 1 to 1.
Yes.
Not 0 even, right? So now what do you see this? We know that sine function, what is the maximum value the sine function can take? It's 1. And what is the minimum value that sine function can take?
Minus
What is the
1.
minimum? Minus 1.
Minus 1.
Maximum is
Okay, can someone tell me what is the maximum value for this function?
5.
5.
So see, most of the time what happens is, I know some of you might get doubt, okay, he's telling this, but there are some point where we get the maximum. This is one case. But what is happening over here, the 5 is in product, but this is only the function, right? So maximum value for this function is 1. So this 1 times 5 gives you 5. But look at this, this is just sine 2 by x, right? No matter what value you take, this is inside only, right? So this will definitely throw a value between these two things. Okay, I hope you get it here. Now, having known that you understood. Now what? Okay, so this is something I understood. Now look at this function, x square, okay? Except 0, when x is not equals to 0, this is always positive.
positive.
Yes, always positive.
Yes.
So can I multiply this throughout this equation and the inequality remains the same because I'm just multiplying the positive value throughout. So what am I doing?
Yes,
here is
sir.
I'm just saying x square minus x square sine 2 by x is lesser than x square. You see the inequality did not change because this is just always going to be positive, right?
Yes.
It's like I'm multiplying with 10 throughout. You understood? Or let's say I'm multiplying this first equation, or this is not an equation, but this first inequality with some value, let's say 100. So I have just done that. And why am I saying 100? Why am I not saying minus 100? Because this function will never take minus 100. It will always give me positive value. So since I'm multiplying this entire function with a positive value, this inequality remains the same. Now comes the thing. Now if I call this as h of x, and if I call this as f of x, and if I call this as g of x, if I call this function, and now what is that limit I should do? Now if I say that limit x tends to, let's say, 0, over here also if I say limit x tends to 0, and over here also if I say limit x tends to 0, what happens to this function when limit x tends to 0? Could you tell me?
0.
0.
What happens to this function when x tends to 0?
0.
So naturally I can say that this function also tends to what? 0.
0.
Okay, so now I got what? When limit, so this implies that limit x tends to 0, f of x, or basically I can say that x square sine 2 by x is equals to what?
0.
So I understood this now, right? Using sandwich principle, I can happily say that this is what happens, right? So now limit value, though I got it. Now when we are checking continuity, there are two conditions. Remember, you first check what? You first check limit, whether the limit exists or not. I say that limit exists. Can I say this limit exists? Yes. So
Yes.
this is
Yes,
my
sir.
first condition. That is my first condition I have used. Now what does second condition tells you about discontinuity? That f of 0 is what? What is f of 0?
0.
0.
0. Can I say that limit x tends to 0? F of x is basically f of 0, and this is actually 0, right?
Yeah.
It's basically same.
Yes.
So can I say that this is continuous?
Yes.
Yes, sir.
This is
Therefore, I can say
continuous.
that this is continuous. And now again, just to retell you again that we are just checking for 0 because we know that at all other place except 0, we know by intuition and we can visualize that this function was continuous. The only place that we cannot visualize was 0. Right? That's why we did some mathematics, right? Right? Are all of us on the same page? We
Yes,
understood
Yes,
this?
sir.
Yes.
Perfect.
Sir, can I ask a question in this inequality?
Please. Yes,
Sir,
yes.
sir, if we divide the all thing by 1, the equality sign change?
No, it will not change. Again, it will see. It's just that minus sign which changes.
Sir, can you please explain this? Because I
Okay, fine. So let's just take one example here. So let's say this is -1, and let's say maybe I can say this is x, and let's say this is 1. Okay.
Yes.
Okay. So now understand this. When I multiply this by 10. Okay. So what do I get? This turns out to be -10. This turns out to be 10.
Inequality.
And this is going to be 10x. Now what happens if I multiply with -10? Then what happens?
Inequality changes. Inequality sign changes.
So now look at this. Now for this one it was perfectly fine. But when I multiply this with -10, what does it happen? So this will turn out to be what? +10. Right? This will turn out to be what? -10x. But look at this. What sign am I using?
Yes, sign.
And also this turns out to be minus. So now what you see that naturally the sign changes for this, because earlier how it was, x was lesser than -10, but what are we saying here is it's essentially the same thing, it's just written in a different way. So you just tell it this way. Okay.
Only sign change when only inequality change when sign change.
Only when the sign changes, that's all. Okay. I hope you understood that.
Yes, sir.
So now you see this, how many 3 problems we discussed, and what should we take on this? There were like, we understood continuity and differentiability, and there are some questions in continuity and differentiability where we use some sandwich principles. Now let's say this is, we directly ask, now this is one type of problem where we directly ask you to find out whether the function is continuous in the given domain or whether the limit exists in the given domain, right? There are third type of problem that you also expect is, we say that this given function is continuous, okay, and then we ask you to find out the values. Now this is second type of questions that you can expect. Now you see this, find the value of a and b such that this function is defined by this is continuous. Now in the question itself I am saying that this is continuous. You don't have to check for its continuity and all, okay. But what am I asking in this particular question is, I'm just asking you to find out what is the value of a and b when this function is continuous. Okay, so this is second type of problem that we can ask you in the exam, right? So how do you solve these kind of questions, right? So now you see this, they are saying it is continuous. Okay, fine, it is continuous. So what do? It means what? Limit x tends to some value a, f of x is basically limit functional value at that point, right? This is what it means. Right now in the question they are saying it is continuous, that means I can think that yes, the limit exists, right? I can happily think that, right? So now which are the places that I should be worrying about? Whenever you get a questions like this, the places where you should worry about is the places where it is the transition is happening or where there is a kind of a breakage, right? So where should you check actually? At x
0 and -2.
So 0 and -2, this is where you should check, right? Because you see at 0 there is some kind of transition, and at -2 there is some kind of transition. This is where I will have to check. Why? Because you see this function, this is a linear function, this is also kind of a linear function, this is a constant function. Again, all of these are a continuous function, right? The only place that I have to worry about is this breakage places or the transition places, right? So I mean the other way of saying is a transition places. So now what, this is the two places, and that is where I will get the value of a and b. So now what, now let me check what happens when limit x tends to a, or let's say 0. So what is my f of x? Can you tell me what is limit x tends to 0 f of x gives me?
B.
Okay. So if this is the case, it basically means what? Limit x tends to 0 minus f of x. Now tell me more about this. Which is the function you should be using? This one?
Second one.
Oh, sorry, second one, yes. So what do you get from this?
B.
So just you get b from here. And what about this? Limit x tends to 0 plus f of x?
4.
0 plus. So you are coming from positive side, so you get it.
Last
4.
one.
So now if this has to be, because we are taking, so can I say that b is equals to 4 from here?
Yes, sir.
Because they're saying it is continuous, right?
Yes,
they're
sir.
saying it is continuous. The limit has to exist. For limit to exist, b has to be equals to 4. Right? right? No doubt over here.
Yes, sir. Yes,
No
sir.
doubt, sir,
Because
right.
got it.
Limit extends to 0. Sorry, this is all about limit. From limit I'm concluding this, but remember this we are telling is a continuous function. Now what is the functional value at 0?
It's B.
It's B, right? So we know that, okay, from here itself I can just make an understanding that the limit, from the limit functions I got that B is equals to 4. So basically I can say that functional value is actually 4 for this. F of 0 is 4, right? So having known this, now this is one part that I got what is my B. Okay, now look at this part here, this part. Now the next place is at -2. So maybe I can just write down here at x equals to 0, we checked it, and at x equals to -2, let's see what we are getting. Okay, so now what about limit x tends to -2? Which function should you be using? This one, or this
The
one?
first one.
First
First
one, sir.
First
So
one.
what is that? What is that we get from this?
-4.
-4.
-2 plus 2.
-4.
-4.
-4.
So this is going to be -4, right? And what about limit x tends to 2 plus? Which function should you be using?
Second one.
Second one.
Not the
Second one.
third one. Understand this, because you find in that
Oh.
small interval. Okay, this is what we do. So this is going to be ax plus b. So this will give you what? So sorry, it is 2 minus, right? So this will give you what? Minus 2x plus b.
Minus.
Now from here, if I substitute b value, what do I get?
Minus
Minus
2x
2x
plus
Minus
4.
4.
Minus
Plus
4.
Plus 4.
Minus.
But again, this is something I got it, but this should be equals to what?
-4.
Minus 4.
Minus 4.
This should be equals to -4, right? Or okay, so I can just simply write that this has to be equals to -4. So when I solve this, what do I get? I just have to take it to the other side. So this will turn out to
It's
minus
equal
4.
to
X is equals
2.
to
4.
So I got that x is equals to 4 and b is also equals to 4. You can do
A
it.
is equal to 4. Minus 2a plus 4.
Okay, so this was a, right? I'm sorry.
Yes.
Yes.
Minus 2a plus 4.
So this is a. So
Sir, I am not able to understand means why we are taking at x is equal to 0 negative. That is from left side we are taking it b, and from positive we are taking it 4.
which one? At this, is it?
Second line, sir.
Here.
Yes, sir. Yes, sir.
What is that you're not understanding?
Why we are taking from 0 negative? It is b.
Okay.
Means are we
Okay,
substituting?
I'll tell you this. 0 negative means you are coming to 0 from the left hand side.
Left-hand side.
Left hand side. So which equation should you be using? This one or this one or this one?
So second one.
Second one. So when you substitute 0, what do you get from this?
B. Okay.
This one you got B.
Hmm.
Okay.
But how to means how to find if means which equation to use? If it is x is less than -2, then we should only take values from minus.
Just draw the number line. Just draw the number line. This is -2, 0, and rest all places you know. When you want to approach 0, you'll be approaching in this interval only, no?
Yes.
Right? No matter from how far you are coming, but you essentially will be using this. So whichever equation is given for this region, you'll be using. Look at this. This equation was given, so you'll be using.
Okay, so we have to consider it means
Ah.
because it is limit, so it is not actual value, so we can consider the first one, right? First equation, second equation. Got it, sir.
Got it? Okay.
No.
Okay, so great. So now if you got this, so let's go with another interesting problem. All of us face difficulty in these kind of problems. I mean, most of us at least.
Yes.
Is there anyone who don't face problem in this? So there is no one who don't face problem in this. Great. So let's check this out. How many of you?
I didn't try it, sir.
Okay.
Everything.
No. What I meant to
think
say
it
is
given,
looking
but still.
at this function, most of us tend to give up. You know, this is what it happens. See, whenever you see mathematics, like, or what I would say is, like, you see, whenever we look at the question, most of the time we look at the question and we tend to give up in the very beginning itself, saying that, okay, this can't be done, right? Look at this function. I mean, if you are not familiar with ceiling and floor functions, this is always we feel like, okay, this is kind of scary. Like, this is not our cup of tea, because this is something different function. It's not the normal functions like exponential or like polynomial or something, right? So we always have that kind of small phobia with this. But don't worry about this. This is very easy once you know how does this function.
This is true for me. This roof function and ceiling function, this ceiling function and floor function. Whenever I look this something, I didn't get it.
So now so you don't really, you just treat it as a normal functions, like the way you see it for this the other function. So here the question is, a function, consider a function this f of t is equals to a ceiling function of t plus n if your t is between 0 to 2, and it's a floor function t minus 1 if t is greater than 2, right? And it is defined something like this. Now what you have to find out, for some integer n, if f is continuous at x equals to 2, it says what? This is the place where you can think of it is some kind of problem which is creating, right? At 2, right? So at 2 there is some kind of a problem. So it is saying that it is continuous at 2. Then what is the value of n? So it's basically just like the previous question what we did. We told that this is continuous, okay? And you have to find some value a and b. Over here also we are saying this is continuous in whatever the domain it is, and we are also saying it is continuous at x equals to 2. Specifically we are telling it. I should have even not written that x equals to 2. Rather, you should have figured it out where you should check that. But it's okay if I have given it is continuous at x equals to 2. What will be the value of n? That is something we'll have to find out. Okay. So those who are very good at this, can you start solving and tell me what is the value of n? So those who are smart should do by yourself, and I mean very super smart I should say, and those who are smart can be with me. Okay, so let's solve together. Okay, so now what do we really mean by this function? So you can just understand this. Okay, so I have taken some examples here. So look at this. This is called ceiling function. Okay, this is called ceiling function, and this is called floor function. How does this graph look like? I'll just tell you graphically also how does it look like. So now ceiling functions. So a ceiling function tells you what? It's basically, I'll just draw the graph for this. Okay, so when between, let's say if this is 1, this is 2. Maybe I should draw a bigger graph so that you will have a better understanding. Okay. So now this is 1. Sorry. So yeah. Likewise, you can talk about it. This is something like this. Okay, so now this is my x-axis and this is my y-axis. Okay, so now what a ceiling function tells you that. So here, if I have to tell you that a ceiling function gives you always the upper integer value. So if it is 1.2, so what is the next integer value it is approaching to?
2.
2. So that will be the output. So 1.2, for an example, look at this graph. What is 1.2? So 1.2 is here. So if this is 1, this is 2. So what is the ceiling value of this? Ceiling value is the next integer value. So the first integer value is 1, and this is actually going to what? Next integer value, right? So it is approaching where? It is approaching where? It is approaching to 2. So therefore, it is always give me output 2. So no matter what value you take in between this, it will always give me output as 2. So what is ceiling of 2?
2.
Okay. So it's not that next integer value means you should give it 3 here. Okay, it's like 2 point something, then it should give you 3. Understood? So now
Yeah.
likewise again, what is the ceiling of 1.9? Ceiling is that you can think of a floor. What is I mean, not a floor, but a roof. What is the roof value of 1.9? It's going to
2.
give you 2, right? So because this is again approaching to 2, right? Now this is called as floor function. So now how will the graph look like for floor functions? Okay, so let's draw it here as well. So how does the graph look like? So it's going to be something like this. So it's just that, you know, it's not that exact value. I mean, it's not the ceiling value, but the floor value. So over here, the graph is going to be something like this. So you notice this when I'm saying floor value, so I'm encircling the, you know, the floor or the least integer value in that particular given, you know, a decimal values of that x, right? So over here too, this is going to be something like this. Likewise, so this is something going to be like this. So now this is what? This is for my floor function. This is a graph for this, and this is the graph for this. Okay. Now look at this function. 2.1. Now if this is 1, this is 2, and this is 3, and this is what? This is again 1, and this is again 2. Now you tell me, where does this 2.1 lies? 2.1 is
2.
Right? So what is the value you get? So you mean
2.
all we mean to say is we have to what? You have to take the least integer value when you take these floor functions, right? Floor means you can just think that okay, you are taking the ground value, or like, you know, the ground integer value. So 2.1, or let's say a 2.9 also, what is the ground value that you get, or what is the floor value you get? You get 2, right? So we understood this part, right? So now we understood that ceiling function is like, if I have 1.2, then I have to take what? The next integer value, that is 2. Or let's say if I have 5.9, what is the ceiling function value for that?
X.
6. So it's that. And what is the floor function value for that?
5.
5.
Clear? So now we understood that. That's all, right? So even if I don't know the graph, I can actually think of that. Yeah, this is what I'm talking about, right? So now look at this function, which is given to us here. Okay, I can just minimize a bit. So now it says what? Look at this. This basically tells you what? This tells you what? A ceiling function, and this tells you the floor functions, right? So now in this particular case, what is, so since they're saying this is continuous, so what should I do? I should do this LHL, right? And where should I do this? Limit x tends to 2 minus.
2 minus.
2 minus. Why? Because they are telling, this is where I can think of there can be some kind of breakage, right? So when your limit x tends to 2 minus f of t, which function should you use? So this is not x but t, right?
First one.
First.
So first one means it's going to be
T
this,
plus n.
t
Plus
plus
n root,
n,
roof function.
right? So this is going to be t plus n. So yes. So now when you're approaching from left hand side, now what? When you're approaching from left hand side, you're approaching to 2, right? You're approaching to 2. That means you are actually going with 1.5, 1.6, 1.7, and you're approaching to where? 2.
2.
So what is the output that it should give me this? What should
2.
give me this?
2.
2. This is going to be 2 plus n.
N.
Right? Clear?
Right, sir.
Right? Now look at this one. Now I'll take my RHL. I'll come back to this again to those who didn't understood this. No problem. So when I'm coming from right hand side, so now you will tell me, like, since why did I choose this? Because when I'm using this left hand limit, so I must be using this function. When I'm coming from right hand side, which function should I use?
Second one.
Floor functions.
Second one. Floor function.
So this is going to
T
be
minus
t minus
1.
1. So now what will this give me?
1.
Now look at this. Now I'll come to this. So now what you are coming to, what value you are coming to 2 from where? Let's say from 2.5, or maybe I can just write
It
down
will be
from
2.
2.5, or let's say 2.4, and let's say 2.3. So you're approaching to where?
2.
2. So what it should
Then
give me the
2
value?
minus 1.
1.
1.
So this should give me what? 2 minus 1.
Is equal to 1.
And why am I telling it 2? It's just because this is a floor function and I should be taking this value, right?
Yes.
the floor value of that integer, right? So that is why this is 2 minus 1. Now what? This is a continuous function. So the limit should exist. That means LHL should actually be
2
equal
plus
to
n is
RHS,
equal to
right?
1.
So 2 plus n is actually equals to what? 2
1.
minus equals to minus 1.
N equal to minus 1.
So what is
Yes,
that we had to
I
find
did
out?
it.
Good.
I was not sure that I did it right or not.
Okay, good, good. So you understood, or you want me to summarize this?
No, understood.
Okay,
I
you
just got
understood. What
scared
about
to.
others?
I just got
Got
scared
it,
about that
sir.
expression.
No problem. Yes, yes.
You are in that super smart category.
Yeah.
I don't think so, but I did it, but I thought maybe I don't know I was right or wrong.
Sir, how is this roof and ceiling? I think what is this ceiling and I don't remember that term. How it is different from GIF, greatest integer function? Is it any difference?
A greatest integer function is something you use this floor function, right?
Yes, floor function.
Floor function. Okay.
This is the other name
And
for
least
that.
integer function is ceiling function.
Yeah. So other name also you can write down. This is greatest integer function, and the other name for that. Okay, so this is.
But sir, when we represent greatest integer function like in notation, it is used as square brackets, not like this. So I just asked.
But we essentially do this. That is why.
The function is same. What we
it's
are
not
doing
right,
actually is the same.
Exactly. So okay. So now I think all of us are smart, so we understood this, and I don't think so there is a repetition required. So if you at any point of time you felt this that you have forgotten it, you can rewatch this video and get it. Okay. So now let's go to the next part. Next questions. Maybe I can just discuss. This is something we discussed here. Okay, so that's fine. So now let's go to the next one. So okay, so we understood somewhat like some questions like how, which was that question number? Yeah, so that was 5. Okay, so let's go to question number 6. Okay, so I'll have to write some questions out. Okay, so now we are fine with finding limits and continuities. Are we okay with this? Do we have any problem in this? No, right? Or do you
Yes,
still
no.
face any problem? I guess you're
Only when we had
Sir,
problem when we face the problem.
one basic quick doubt. We have discussed about addition, subtraction, multiplication, and division. Sir, what about the composite function? Like if f of x and g of x are both a continuous function, so f of g of x and g of f of x will also be continuous in its domain. We can say that.
In its domain, that is
In
the
its
condition.
domain, yeah, the domain should
you
be
have to
mentioned.
yes, yes. Because the domain will change for that composition of it. Right?
Yes, sir. Yeah. Thank you.
All right. So now again, so now let's go with some standard things like what do we mean by differentiability? Okay. Now we understood limits, we understood derivatives. Now, sorry, not derivatives, but continuity. But what do we mean by this differentiability or like derivatives? So now, what do we really mean by this? So again, this is a concept of this is where you come again with the limits. Okay. So the formal definition for this is you say that this is somewhere like, maybe I can just say that limit h tends to 0, f of x plus h minus f of x upon h. Now, if this exists, then I say the function is differentiable. Then function is differentiable. Okay. So now, what do we really mean by this? Differentiable at x. Now, this is also important. So now you see this is again a limit, which is something we are doing it from that time, right? So we understood, okay, this is again a limit. So when I'm writing this, it essentially means what? Limit h tends to 0 minus when you're solving this, and limit h tends to what? 0 plus, right? This essentially we do, right? Whenever we write like this, we in backend, what do? This is something we do, right? Just to check whether the limit exists or not, isn't it? So whenever we get a questions like this, we also do what? These kind of operations like left hand limit and right hand limit for this particular function exists or not. And see, the normal notation for this is f dash of x. So f dash of x, it actually means this. In our 11th and 12th, what we have done is, of course, even there we talk about the first principle definition. This definition is called as first principle definition of derivative. Okay, so first principle definition of derivative. Okay, so this is the first principle definition of derivative. So what does this tells us is, now you see this, when limit h tends to 0, f of x plus h minus f of x upon h exists. If this exists, then we say that this function is differentiable at x. If it does not, then we say it is not differentiable at that point. Okay, what do we graphically means? Now look at this function. Okay, now if I have to tell you that, now let's say if this is my curve, okay, and this is your x where you are finding it. Now let's say this was your x. So what are you doing is, differentiability is nothing but it's basically a kind of a slope, you can see. Now f dash is nothing but, you would have remember, if you remember, we used to have this formula y2 minus y1 upon x2 minus x1 was giving us what? A slope, right? This
Yes.
is what we were getting it. In other words, I can even say this, I'm claiming that I can even say that this is f dash of x. This is something I'm claiming. How do we do this? Let's see this. Now look at this. If this is my x, okay. So now I'm taking one more point from here. Let's say this one, okay, and this is something like a difference is h. So this is going to be x plus h. Okay. So now if this is my curve, now I have a 2 points. Now if I have to zoom this, so it's essentially it's going to be what, like this, and this is x comma f of x, and this is going to be x plus h comma, maybe I can write down here, x plus h comma f of x plus h, right? Understood? Now these are the 2 points. These are the 2 points, right? And now what I have to do is, now I'm finding a slope. Now just understand this. Now what am I doing? I'm finding a slope. So now how do I do this? y2 minus y1 upon x2 minus x1. So what is that? F of x plus h minus, what is this next one? F of h upon x plus h minus x. So when I simplify this, what do I get? F of x plus h minus f of h upon this x, and this x will get cancelled and I'll be left with h. So essentially what is this giving us? This slope, and I'm saying this line passes through this, right? This is what I mean, right? Now look at this. When this h becomes smaller and smaller and smaller and smaller, what happens? The straight lines shift over here and it goes over here. Can I say that? When x is very, very small.
Yes.
Can I say
Yes,
that?
sir.
So essentially what? When h is tending to what? When h is tending to 0, when this h is actually going to 0, that means it's becoming very, very small. Then what am I getting? Am I getting a straight line? Yes, I'm getting a straight line. And what is that straight line indicates?
Tangent.
It's a tangent.
Tangent, yes. So basically it gives you what? Tangent is basically a line. So it is giving you what? This is basically giving you a slope at that particular point, like for that certain x value, right? So that is what we understood from here, isn't it? I hope this is okay, clear to all of us.
Yes, sir.
Okay, so this is what we mean, like, okay, you are approaching to this value, and essentially what do we mean? We are finding the slope of this curve at this point, right? This is what we are doing. At x equals to something, at this point I'm finding the slope of this curve, isn't it? Because this gives us slope, right? This gives us the slope. So that is the slope value. But how do you get the tangent? Tangent is basically a line. Tangent line is basically a line, right? So how do you get that line? So basically we know that at this point I got the slope through this f dash of x, and since I have the point, can I use this point slope form to get the line of that? I hope you remember point slope form.
Yes, sir.
Do you remember? So now
Yes,
from
sir.
here,
Yes, sir.
I know what is the point, because look at this. I know what is the point, and I know the slope at this point, right? So I have the slope, I have the point, I can get the line, right? So I can get the line of this curve, right? So I can get the line for, basically I can get the equation of this line, and that line is called as a tangent line. So for a tangent line, you require what? F dash of x and a point. Am I clear on this? For a tangent line of a particular curve, At a particular point, what do we need? We need two things. What is that? We need a slope and we need a point, right?
Yes.
Right? F dash of x gives you what? F dash of x gives you the slope. That's all. These are the two concepts that we have to know, right? Then how do we actually find this differentiability? How do you actually do this derivatives, right? So this is something we know it. Now we understood what is the graphical aspects of differentiability. What is that happening over here? We understood what is derivative, and we also understood what is that line representing this curve, right? So there are two concepts which is coming out from here, right? So we can keep those two concepts here, or maybe I can just give you a line. There is something called best line, not best line fit, but I think linear approximation. Some term was given, right? Linear approximation. So what do you mean by linear approximation? I can just discuss that concept here. So basically, this is giving you what? Slope. Now I can just discuss this concept over here too, and then I can discuss more on derivative and L'Hopital's rule and discuss more problem on this. Okay. So now this is what? Linear approximation. So linear approximation. So now what do I have? I have what? A slope. So what is the slope that is for me? Let's say this is f dash of x, and what is the point I have? What is the point do I have? X comma f of x. This is the point I have, right? Agree with me?
Yes, sir.
Okay. So now let's say this x is, let's say, a. That means over here, this is some value, let's say 5, 10, 12, whatever. I'm saying x is a. Okay. So now what is the slope for this curve then? F dash of a.
F dash of.
What is the point I have? Point is a comma f of a, right? Now you see this, I have a slope and I have a point. Can I not find the equation of a line? I can do this.
Yes.
Right? So equation of this line is going to be, let's say, L of x. Or maybe this is like complex terms. How do we get the equation of a line? Y minus y naught. F dash or maybe
m into x minus x naught.
M minus x naught. Okay. So now what am I saying is, okay, this is what this y indicates that line, right? So I can simplify this and I can write this m times x minus x naught plus y naught, right? And what is this? Let's say this is my, since this is linear approximation, so let's say this is LT of x. Okay. Or let's say, yeah, fine. Or not LT of x, or let me just say it as Lx. Okay. So let's say this y is nothing but L of x. And what is this m? M is nothing but the slope, right? And what is my slope? Y dash of a, right? And what is the value that I have? Am I audible?
Sir, I think you are facing
Not
internet
for
issue.
me,
Your voice
sir.
is so much choppy.
Not able to understand, not able to hear properly.
Okay.
So this is the formula of second.
Okay.
Right?
Just give me a minute. It should be fine. Just give me a minute. I'll just connect with different Wi-Fi.
Okay.
Now it should be fine. It's stable now.
Yes,
You can
sir.
hear me? All right. All right.
So this is the formula of second.
Formula of
Second. So the things are taught that second thing. I didn't get it properly. Second.
I don't know what is that second, but this is so what does this means is I don't know, maybe second. What is that second?
The 2 point on the curve, when they are going near, this is almost near to the tangent.
Right. So essentially this means what? When you do this linear approximation, so what do we actually mean by this is, let's say you have a curve like this. Okay, now I have to represent this curve by a single straight line. Okay, so let's say at this point it's some value a, And at this A, I want to represent this entire curve by a single line. Okay, so how will I do this? Which line should I use? Should I use this line? Should I use this line? Should I use this line? Which is that line that I should use so that it gives you a linear approximation of this curve at that point? Okay, so that is something we get it like this. Okay, so in other words, if I have it's a very vague curve, it's something like, you know, very random curve here and there, and I tell you, okay, represent this curve by a single straight line at this particular point, then what you should do? You should find the slope, and you have already have the point because we are specifying what is the point. So now all you will have to do is you have to find out the slope. Now find the slope, fit in the equation, and let's get the line. That line is nothing but the best linear approximation of that curve at that point. Okay, so I hope you got it. Right?
The linear approximation and tangent both are same only. Sir.
Correct, correct. So tangent is basically a line, right? Both are same. Tangent line is the same. So now let me just give you a quick question, a small questions on this. Okay. So now let's say this is question number 6, and so maybe a very small question, and I think you should be able to answer. Find the equation of the tangent. Find the equation of a tangent of a parabola f of x is equals to 4x square at point 2, 16. Now this, all you have to do is you have to find the equation of a tangent of a parabola f of x equals to 4x square at a point this. So I am telling you, find the equation of a tangent. So it's basically going to be a line. Tangent is basically a line, right? I told you earlier that line, the slope of this line is basically the slope of the curve at that point, right? So now find the equation of the tangent of a parabola f of x equals to 4x square at a point 2, 16, right? So now what is the answer for this?
8x.
What? 8x. So first of all, what you should do over here is you have to first find out the slope of this line, right?
Yes.
So how do you get the slope of this curve? Slope of f of x is
2x plus b.
So that is giving you 8x, let's say.
Yes.
That gives you 8x. But x is what? 2, right? But x is what? 2, so this should be 16. So slope of f of x, so in other words, f dash of x or f dash of 2 is nothing but what? 16, right? So in other words, let's say if this was my curve, 4x square, and where is this point then? So at 2, right? So 2, 16 is somewhere like here, 2, 16, and you had to find out the equation of a line which is passing through this. It's something like this. This is your tangent line, right? So you notice one thing, the slope of this curve, at this particular point is basically the slope of this tangent line at that point, or like it's basically the slope of this tangent line, isn't it? So at this point, whatever is the slope of this curve is same as the slope of this tangent line, right? So from the given curve, I got to know what is the slope. Now what I have to do, I have to find out the equation of a tangent line. Now tangent line is passing through what? This point.
6.
Now I know the slope.
2 and 16.
So now I have this. So what this is going to be me y minus 16 times 16 times x minus
2.
So this is going to be 16x, and this is going to be what? 32 and plus 16. So this is going to be y is equals to this. So y is equals to 16x minus 16, is it? So this is going to be
Yes,
16 x minus 1. So this is some equation, you get it, right? So this is the equation of this tangent line. Okay, I hope you got it.
Yes, sir.
Okay, from this equation of a line, could you tell me what is x-intercept? Let's see how many of you are smart.
One.
Yes, 1. 1 is the right answer. because you remember we had this x-intercept form
Okay, yes,
minus b, right? So you have
yes.
to be alert. Yes. Okay, great. So now having known this, now we understood like somewhat vague understanding we are getting. Okay, if something slope and line representation thing. Now let's do one. I don't know if you want to do a linear approximation question. So should we discuss one question on linear approximation?
Yes, sir.
Okay. So let's discuss one.
So please take 8.4 question is there, the linear approximation question. I have doubt on this, so we can discuss now.
8.4. 8.4 your activity.
Yes, sir, 8.4. Last question, sir.
This one is it?
No, sir, last question. Linear approximation.
This one.
Yes, sir.
Okay. Just a minute. Okay. So before going to that question, I want you to solve one more question and then we can take up that question. Okay. So I'll just paste that question to time being here. So now you see this, we have a question like this. Now, let's say let f of x be differentiable. Okay. Differentiable at x equals to 1 and f be represented by the curve. So you see, we are actually running short of time. So what I'll do it right now is I'll discuss this question and this question, and I'll discuss one more question on differentiability. But I'm not touching up L'Hopital's more questions on L'Hopital's rule and derivative formulas based questions. Okay, so that is something in the next session can be taken. So those two topics I'm leaving, but after these two questions, I'll be taking one more question that is kind of important and it is like frequently asked. So I'll discuss that question and then we can end our session. More things on L'Hopital's rule and more things on the formulas of derivative shall be discussed in the next lecture, and you yourself should also practice. Okay, so let's do this. So now let f is differentiable. Let f of x be differentiable at x equals to 1, and f is represented by the curve C. Okay, if a line, okay, which passes through, let's say, if a line which passes through the point, pardon my bad handwriting, but at least you also make a note of what I'm saying, at a point 5 is tangent to the curve C at a point, let's say 1, 0. Okay, then find the value of f dash of 1. Now this is a particular question. Okay, so now let f of x be differentiable at x equals to 1 and f be represented by some curve C. Okay, but what are we saying? That f is differentiable at x equals to 1. That means f dash of 1 exists. Okay, if a line which passes through the point 5, 8 is the tangent to the curve at a point 1, 0. So essentially it means this. Basically, if I have a curve and if this is 1, right? If this is 1 and this is f of 1. So you have a line, you have basically a line which passes through this it basically it passes through this point and it also passes through 5.8. Okay. Okay. Then you have to find out what is this f dash of 1. All right. I hope you understood this question. You understood? Yes, no, anything?
The slope. We have to calculate first the slope.
You have to find out this slope, right? So slope, no, you have to actually find this slope. So how do you find the slope?
2 points are given, so we can easily find that slope, right? y2 minus y1 by x2 minus x1.
Okay, that is one way. Definitely you can do that.
The solution is 16.
Solution is what?
16.
F dash of 1 is what?
16.
That's 2.
It's 2 actually. Yes, that's right. But how do you get it?
Sir, because f dash 1 is also the slope of that line. We by using linear approximation.
Yes. You can use linear approximation and get the answer. But how is that thing done, right? So now we know that our linear approximation tells you what L of t is nothing but what? F dash of 1, right? And this was x minus 1, right? Plus f of 1, right? This is what it was, no? This is what we arrived at, right? This is what the formula for our linear approximation, isn't it?
Yes, sir.
So now how do you go about this then? So this basically L of t was nothing but this was what y, right? L of t or instead of L of x, right? So now you see this, it tells you what at x equals to what? At x equals to 1, what is this y value or what is this L of x value you are getting? 0, right? So now what? This is going to be 0. This is f dash of 1. And this is going to be x minus 1. Sorry, x is what? 0, right? So 0 minus 1. What is f of 1?
Again 0.
F of 1 is? Oh, wait.
0.
Am I doing mistake somewhere? Sorry. It passes through the point. So this is basically, this line was what? This line was representing what? So this basically, I'm using the same point and you're finding it. So you see this, this L of x is this, right? This is my L of x, right? Right? Now it passes through this 5, 8, isn't it? So what is this is 8, f dash of 1, right? And what is the x value that I'm getting? 5. So 5 minus 1. And what is f of 1? F of 1 is? F of 1 is 0. That is something given to me, right? Now this is right. So now how do you get this? This is going to be f dash of 1. So this is going to give me 2, right? I'm just simplifying this. This gives me 4. And when I divide this, I get it 2. So I hope you got this. You understood this?
Yes, got it, sir.
Got it?
Sir, f of 1 will be 0, right? But how?
Because it is given, no? See here in this question, the term passes the tangent because it's given. For 1, you get the output 0.
Okay.
Right? That's how you work it. All right. So now using the
Sir,
linear
could we have used the slope formula that we have y2 minus y1 divided by x2 minus x1?
That is the easiest way you can do it. But I wanted to give you an idea about your linear approximation. See, you were able to tell this that you can use that slope formula. It's just that it indicates that you know the concept very well. You understood?
Okay.
Yeah.
So it doesn't matter like if this is written tangent to the curve C at a point 1, 0. So we just normally treat it as a point and we don't have to care about f dash of 1.
But this is this understanding comes only after you understand this concept, right?
Okay. Yes.
So since you understood that, it's perfectly fine. You can use that is something advanced level of thinking that yes. Now this is what it essentially means. So it means this, right? So that is something you can deduce and do your problems, right?
Okay.
Definitely you can do.
Right.
Okay. So now using a linear approximation of f of x at x equals to 0, the approximate value of 1.01 to the power of 4 is what? Okay. So now could someone help me out in solving this question?
we have to find first f dash x.
Okay, so what is f dash of x?
4 1 plus x
Whole cube.
into 1. This is this thing. 4 into 1 plus x whole cube.
Okay. So to all those who did not understood how we did this is with the direct
Are we
formula we have done it. Oh no, I made a mistake, right? This has to be yeah, this is fine, right? So
Yeah.
Derivative, right?
so now you got this f dash of x. Now what is the next step?
And now to find the f dash of 1.01. No, we have to find the
F dash of
formula. Then
zero.
X
at
minus
zero, then we have to find that f dash 0 and f 0.
So what is f dash of 0?
F dash of 0 is 4.
Okay, and then what do you do?
F0. We have to find F0.
What is f0?
F0 is 1.
Okay, and
then we have to put the formula f dash 0 into x minus 0 minus
okay,
x minus
f dash 0
a, x minus a,
x minus a plus
plus fa. F0.
Sir,
Okay, but
I
what
am
is
doubt
a?
here only, sir. Why we are putting a, sir? But it should be x minus 0.
Just filling the formula. Actually, just formula came over there.
Okay, no problem. Now you can do it, right?
Yes.
4x
now,
plus 1, sir.
Sorry, what?
It will L of x equal to 4x plus 1.
You get what? 4x plus 1.
Yes, sir.
So yeah, so f dash of 0 is what? 4x, and this is giving you what? 1. So 4x
4x plus 1, right?
And then what do you do next?
We will put 1.01 to L of
Approximate
x.
value.
So now what you will do this? So now
4x plus 1 is equal to 1.01 to the power 4.
So you put 4 power 4.
No, no, 1.01.
So you will just do this and get the value. Okay, so
Sir,
this is going
then
to
we find the value.
calculator, I am not getting this value, sir.
What is that you are getting?
1.04 like that in calculator.
But yeah, actually this should not give us the value. There is some error, definitely. So where is that mistake we are doing?
How f of 0 is equal to 1 means we are taking 1 plus x is equal to 0. It is like that.
Sorry, what?
How f of 0 is equal to 1?
How f of 0 is equal to 1? You just substitute that value in that.
Okay, sir.
Here. Okay.
So how the value of 1.01 ki power 4 is we getting by substituting x is equal to 1.01? I am not understanding this.
I get it. So could you tell me, like, why did you think that you should have to go with this method?
Because approximation using linear approximation it is saying, so we first find the linear approximation.
Right. So okay, so that is one way of thinking. Yes, since it is directly asked over here, so this is how you have to go about. So now L of x is given as now this is the formula, and then we have to find out. But why are you even doing it 0? I didn't get it.
It's given, no, sir. Linear
Because it is safe for x is equal to 0.
What?
It is safe for x is equal to 0.
Okay, at x equals to 0 it's given. So now what? Now where are we making mistake? I think this is the way we do, right?
Yes, sir.
Or maybe I'll just look into this question. Okay. So fine. I'll maybe I can just put it in the forum and maybe I can solve you and send you. No problem. Let me look at this. Like, how is this happening? But I think we are doing some minor calculation error. Okay. And we can get this. Okay, so having known this part, like keeping this for afterwards, let's go to another question. That is, I don't know if this is an activity question only. I don't know if you would have gone through. Yeah.
For the previous question, could we have used that differentiable formula that we have that we use to check the differentiability of a function.
So this is something. Okay, you mean to say that limit function using that
Yes.
limit? Yeah,
Yes.
you can do that. You can do that. But again, using that first principle, we have arrived to a different formulas, right? And with those formulas, we make use of those formulas to find the derivatives. You can definitely do that, but that is time consuming.
Yeah, that is time. As an alternate, I thought to use that.
You can do that, but it will become lengthy.
Okay, right.
All right. So now let's go to the another activity. There is one more activity question. So, and this one I'll look into this. There is some kind of error, and looking at time, we should actually switch to the next one, next question. So I don't know which question number is this, but yes, you have this question: f of x plus y is equals to f of x, f of y. Did you see this question in activity?
Yes, sir.
Yes, sir.
You were able to solve this?
Yes, sir.
Okay, good.
No, I am not able to solve it, sir. Please
No, sir,
explain.
not able to.
Okay, then this is what the question is. Okay, so this is given that f of x plus y is equals to f of x times f of f of y for all x comma y belongings to R, right? Now, if f of 9 is equals to 6 and f dash of 0 is 4, then what is this f dash of 9? Okay, so that is something tells us. So now how do we do this? Now, see, when nothing goes into our head, stick on to the first principle. Okay, so what does our first principle tells us? Okay, so when I say f dash of 9, it means what? It means limit h tends to, or maybe limit x tends to, h tends to 0, f of 9 plus h minus f of 9 by h, right? This is what it means. This is what
Yes,
it
sir.
means. All of you are convinced?
Yes, sir. Yes, sir.
Okay, so now what I can write this as what? Limit h tends to 0. This is another hint which is given to you. F, what is that? Did I miss something? Did I write some point? F dash of 0 and f dash of 9. Okay, so everything is given here. So I can write this as, okay, this is f dash of 0 or f of 0. So this is basically f of, can you look it in the question? This is f dash of 0 or f of 0?
F dash of.
Okay, this is f dash of 0. Okay, all right. So now look at this part. Now limit h tends to 0, f of 9 plus h minus f of 9. Okay, so f of 9 can be written as what? 9 plus 0, because we want to bring it in this form, right? So this is one hint which is telling, okay, that at every places, if you can use this, then use it, right? So now I can do this. So now what? Limit h tends to 0, so this basically h looks like n. So how can you write this? This is nothing but f of 9 times f of h, right? F of 9 times f of 0 upon h. Can I do this using this formula? Right, all of us are here. Now I can do this. Now look at this, f of 9 is common to both, so I can take out f of 9 from here. And now if I do this, and let's take this limit h tends to 0 inside, then I'll be left with what? F of h minus f of 0 upon h. Now look at this one. This is, can I say that this is f dash of 0? This part.
Yes, sir.
Can I say that? Yes, I can say that. So then I'll be
Yes,
left
sir.
with f of 9 times f dash of 0. So what is f of 9? F of 9 was given as 6, I guess, right? So f of 9 was 6 and f dash of 0 was 4. So 9 times 4 is nothing but 9 times 4 is what? Sorry, 9, it's 6, no? 6 times 4 is
24.
So f dash 9 is equal to 6.
Sorry, what? So f of 9 is given as 6 and f dash of
Hmm.
0 is 4. So this together becomes 24. Okay. So with this, I end my session here. And this particular question, I look into it and I'll share you. Maybe we are doing some kind of calculation.
Sir, one question, just e to the power x square cos x. How could I differentiate this thing?
E to the power of x cos x.
E to all in power. E e to the power x square cos x.
E to the power x square cos x.
Cos x, yeah.
So you will be applying your chain rule here. First, we'll do this way. So what is derivative of e to the power of x? E to the power of x only, right? So e to the power of cos x. Now you will be differentiating these two functions. So when you differentiate this, so it will again go in the chain rule. So you first differentiate
2x
this.
2x cos x minus minus x square sin x. Okay.
Okay. So now you have differentiated this.
Okay.
Okay.
Got it. Got it.
Okay,
Thank you,
fine.
sir.
So yeah, all right. So now I'll end my session here, and then I'll take up that questions, and then maybe I'll put it in the forum and discuss both the
Line number 2 for the previous question. I
What?
was just. Can you explain it? Line number 2 means f of 9 into f of 1. From there, can you please explain?
Where? Here.
Yes, from there only. Yes.
Okay, you see this. Basically, what did we do was here f of 9 we took out common, right? And this limit function is something I just kept it because f of 9 is some value, fixed value. So it is just that I have taken it out, right? Look at this one. This is how we are getting it. So now this is equivalent to saying that what is the formula you remember? What is the formula? F of x plus h
minus fh by h.
Divided by h.
So what is here? This is a special case where x is what? 0. And so when you do this, what do you basically means? You write f of x. So limit x tends towards h tends to 0, right? So this is f of 0. So for f of 0, how do you write? Limit h tends to 0.
H.
F of h minus f of 0.
Minus f of 0 upon
by h.
Right? So this is what you get.
So this is the only way to solve this thing, or is there any other way?
This is the only way, I guess. Because
So
I
this kind
tried
of
with other
sum we
people.
have to solve with the by the definition only.
So when that's what when nothing happens with the formula or something, stick on to the first principal definition, you will get that.
Oh, I got it. Thank you, sir.
Sir, I have a small doubt in log derivative. So if we have a natural logarithm, we can simply write ln of x is equal to 1 by x. So is it applicable for base 10, or what if we have other different base?
Just change the base. Just change the base formula, you know, right? How to change the base formula and then do it.
Yes, sir. So the formula 1 by x is applicable only for natural log.
Yes. You're right.
Thank you.
All right. So all right then, maybe I can end my session here, and then we can take up.
Sir, we don't have access to Discourse forum yet. So can you please that on Google forum? That question. Because most of us don't have Discourse forum access yet.
Sure. I'll do it.
Yes, as I don't have.
Okay.
You can access it. You can access it.
No. It's for term student. We don't have a IITM domain right now. We are accessing with Gmail.
Okay.
All right then. Have a good day then. Thank you.
Okay, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.